Welcome to qnawire.
So this question is about numerical integration, and I'm just going to do all this on an Excel sheet and show you the method, but doing every single calculation takes a long time. But if you want to do it by hand, go ahead. I'm just going to show you the quick way. So for each of these, we're given time and acceleration values for the first 17 seconds. And we know that velocity is going to be the integral of the acceleration, and the position is going to be the integral of the velocity. And in order to find those, so we know the starting velocity and position is 0. And then to get this first value, I'm going to take basically the average of the last two accelerations. So the sum over 2, or times a half, and then multiply that by the time interval over those two accelerations. And for all of these, the time interval is just 1 second. And then for each velocity, I'm going to add in the velocity of the one before it. And so for the starting one, it's just 0 plus the average of the accelerations. And you keep doing that down, and you go all the way down until you get to t equals 17 for the time. And you get the velocity is 30.285 meters per second. And the only way to get this is you have to do every single value individually and sum them all up. You can't just go straight to the end value and expect to get an answer. And the same thing is true for position. So what I do is take the average of the last two velocities, multiply it by the time interval, so the difference of the two times, again, 1 second for every interval, and then add in the previous position. And if you do this all the way down, in order to do the positions, you also need every single velocity value, so you have to do all these out. And if you do that down, then you get 304.872 meters is the position at 17 seconds. And doing this with Excel is really quick and easy because you just plug in one formula and then it works for all the rest. But doing it by hand is a pain. Again, it would take me a while to show out every single calculation, but the way you're probably going to be doing this, if you ever do numerical integration, is using Excel for data analysis. So this is just what you would do. You have to step through every value and keep adding them up, and that's basically how integration works, but not analytical, it's numerical this time.